Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we have another beauty of questions waiting for us. So let's get started. Yeah. So today we have this question: divide array into equal pairs. That is an easy type question. So obviously it is an easy. So let's just quickly solve it as fast as we can do. Right. So yeah, let's first understand the question. So in this questions, we have given an integer array nums consisting of two n integers. So that means an even array length integer array is given to us, and now we need to divide nums. We need to divide this array nums into n pairs. So there are two n integers, so we can divide them into n pairs such that each elements belong to exactly one pairs. So a particular elements can go to a particular group of pairs, but so every elements can belong to exactly one pair. So if you were choose any arbitrary elements from the array, then for this there must be an mirror elements exist. There must be the same elements exist all together, and both can club together, both can pair together, right? And the elements present in a pair are equal, and which two elements you are pairing, that should be identical, that should be equal. Yeah, that's two basic conditions we have to maintain, and we have to return true if nums can be divided into n pairs, otherwise return false. Yeah, that's it. Like, that's the very simple questions I altogether have to say, right? Now if you try to understand, solve the questions, what is the first things come to your brain? So as we have to make the array, as we have to make every elements to a group of pairs, so you can, why not you are like gathered them. What is equal elements? So in these questions, on the second constant, it is stated that the elements which are equal are paired, which are equal should be paired. So why not then you have grouped all together the elements, you have grouped all together elements. And how we grouped elements, we can pass the array to a map kind of things, So the key should be the elements, and value should be the count, how many times it has occurred, So exactly same things. Like if I go to the OneNote, so today is nothing I have planned also to do OneNote, but yeah, let's do it very quickly. So let's suppose you have an array, and that is your array 1 2 3 4 5, that is obviously of size 2n every time. So let's suppose these elements has a pair of this, and let's suppose we have multiple occurrences of this. Here is another, and here is another, and this one of same type. So when you are passing it to a map kind of things, which is basically storing the frequency, this count is going to be, this elements count is going to be 4, and this elements count is going to be 2, right? If you have this map in your hand, can you tell me the answer? I think yes, because if every value to our map, so that is one value in our map, that is another value in our map. So if every value is of even number, can we say like these elements can be paired with some in paired with some this, what is the value? So there are four elements altogether. So how many pairs we can form? Divided by 2. If it is even, so there are 2 pairs. So can we say there are 2 pairs? Yes, we can say. So this and this can club to one pair, and this can club to another pair. We are following all the constant to our question, and this can pair to another pair. These two can pair to another pair. So when we have every elements, every entry to our map has even frequency, can we say that it is fine? Like every of them. So can we say we can return a true? But else case, if there is any such pair exists for which the frequency count is odd, then on that case, can we return a false? We should. Yeah, so that's as simple as that. This question should be. So if you can now go to the code. So what we have created the frequency things by taking a default tick and iterate over the array, and we have increased the count for when we are encountering a particular elements. After that, we have iterated over our dictionary altogether, or the frequency map we have created, and we are checking if any particular elements has an odd count in the frequency map. If every elements has an odd count, so then on that case it can't be paired with anyone. Then on that case we are returning false altogether. So that is this is a, like, you can write it in something like this also, modulo 2 not equals to 0, but as I told, like bitwise operations are always faster. So how you can check if a particular number is odd or not in bit manipulation. So its last set bit is always set. Its last set bit is always set. You can read it out. It is very simple. Its last set bit is always set a particular odd number. So that we checked. So that means it is an odd number. And if there is an odd number exists to our altogether frequency map, then from that point we can return a false. From that point we can return a false. So that particular key, there are some existing, there is at least one elements which we are not able to make pair, which we are not able to make pair. So we are returning false. And if you are able to successfully process this entire frequency map and there is no altogether like odd elements exist, then after that you are returning true. You are returning true. Yeah, the question is as simple as that. And time complexity is what? The time complexity on this case is big O of 2n, I have to say, because one times we are iterating to create the frequency map, and another time we are iterating to basically checking the count, if all the elements count is even or not. So that's the reason. So we are again iterating to our frequency map, that is taking another n times at worst case. And on space complexity, we are using a frequency map which is altogether going to consume a big O of n space. Yeah, so that is the time and space complexity for this question, and that is mostly the most optimal solutions for this particular question. And right, so that's it for today. And if you understand our video and if you are following us, then please help us by subscribing to the channels and turn on the notifications for next future updates. Okay, thank you guys. Bye.